Welcome to Archive Preprint Server Daily, AI Frontiers. In today's episode, we'll be exploring the latest developments in computer vision research from May 2025. Our focus is on the cutting-edge advancements in visual AI technologies that are shaping our future. Let's dive into these fascinating developments that are pushing the boundaries of how machines interpret and understand visual information. Computer vision has evolved dramatically over recent years. We've witnessed a significant shift from traditional convolutional neural networks to more advanced architectures like vision transformers and diffusion models. The field is increasingly converging with other AI domains, including natural language processing, robotics, and reinforcement learning, creating more integrated and capable systems. The applications of computer vision now span virtually every sector of society, from healthcare where algorithms analyze medical images, to transportation with autonomous vehicles, retail with cashierless stores, security systems, and entertainment platforms. Despite impressive progress, key challenges remain, including improving computational efficiency, enhancing robustness to real-world variations, reducing data requirements, and addressing ethical considerations. Today's papers showcase both fundamental algorithmic advances and specialized applications across multiple domains. Our first major research theme centers on diffusion models for image generation and enhancement. Lee and colleagues introduced TS-Diff, a two-stage diffusion model, specifically designed for enhancing extremely low-lot raw images. Their approach first addresses global illumination and color issues before focusing on detail enhancement, resulting in significantly improved image quality. Another notable paper, CountDiffusion by Lee and team, tackles the challenging problem of generating images with precise control over object quantities. By incorporating counting-specific guidance into the diffusion process without requiring additional training, they achieve accurate control over the number of objects appearing in generated images. Diffusion models have become particularly attractive for their ability to capture complex image distributions and generate diverse, high-quality visual content. However, they typically require multiple forward passes during inference, making them computationally expensive. Many of today's papers address this limitation by proposing more efficient architectures or inference techniques, reflecting ongoing efforts to make these powerful models more practical for real-time applications in image restoration, synthesis, and manipulation. The second prominent research theme focuses on 3D vision and spatial understanding. Leo and colleagues presented a breakthrough with their ONE2-ANY system, which enables 6D pose estimation requiring only a single reference image. Traditional methods typically require complete 3D models, multiple reference views, or category-specific training, but ONE2-ANY breaks these dependencies by working with just one reference image. Similarly, a S3D by Xiao and team introduces semantic spatial scene graphs for 3D visual grounding, addressing the challenge of locating objects in 3D scenes based on natural language descriptions. These advancements in 3D vision are crucial for applications like augmented reality, robotics, and autonomous navigation, where understanding spatial relationships between objects is essential. We're observing a clear trend toward methods that require less prior information or training data, making these technologies more accessible and deployable. As sensors become more affordable and computational power increases, these advances are enabling machines to perceive and interact with the physical world in increasingly sophisticated ways. Our third research theme highlights multimodal learning, which integrates vision with other information sources. VideoPath-LLaVA by Vuong and colleagues combines video analysis and natural language processing for pathology diagnostics. This large multimodal model integrates visual information from medical images with diagnostic reasoning expressed in natural language, mimicking the diagnostic process of human pathologists. R3VQA by Niu and team focuses on inferring mental states and social dynamics from video content, requiring deep understanding of both visual cues like facial expressions and body language, and social context. Another interesting development is the STOLA framework, which integrates touch and language with tactile common-sense reasoning in open-ended scenarios. These multimodal approaches address complex tasks that require diverse information sources, creating more versatile AI systems capable of human-like understanding. By combining the strengths of different AI subfields, researchers are developing systems that can tackle increasingly complex challenges that were previously beyond the reach of single-modality approaches. The fourth research theme examines specialized domain applications, particularly in healthcare and transportation. Sansir and colleagues created HistoMiner, a deep learning-based pipeline for tissue feature extraction from skin cancer samples. This tool demonstrates how computer vision can augment the capabilities of pathologists, potentially leading to earlier and more accurate cancer diagnoses. In transportation, Jehoda and team pioneered an innovative approach to road safety by predicting road anomalies through tracking preceding vehicles rather than directly observing the road surface. Similarly, Yurnikul and colleagues enhanced YOLO 8 for real-time and accurate pothole detection and measurement, addressing road quality assessment and maintenance. These specialized applications often require interdisciplinary collaboration between computer scientists and domain experts, with domain-specific adaptations addressing real-world constraints and requirements. As the field matures, we're seeing increasingly sophisticated applications tailored to solve specific real-world problems across various industries and sectors. Among the papers analyzed, several present particularly groundbreaking results that could significantly impact computer vision and its applications. Yehuda and colleagues developed a system that predicts road hazards by tracking vehicle motion patterns rather than observing the road directly. This approach works effectively in poor visibility conditions like low light, heavy rain, and dense traffic, where the road surface is partially or completely obscured. The system consistently detects anomalies several tenths before encountering them, providing sufficient warning time. Vong and team created VideoPath-LLaVA, which mimics pathologists' diagnostic process through video analysis. Despite limited training data, they developed a model that generates detailed histological descriptions, culminating in accurate diagnoses. Liu and colleagues introduced ONE2ANY, enabling 6D pose estimation with just one reference image, eliminating the need for 3D models or category-specific training. Finally, Sun and team developed WDMamba, analogens for separator image dehazing by separating low-frequency haze components from high-frequency details. These diverse breakthroughs collectively demonstrate different approaches to fundamental computer vision challenges, from innovative sensing techniques to efficient architectures and domain-specific solutions. Across these papers, several common methodological approaches emerge. Diffusion models feature prominently, offering high-quality image generation and manipulation, but remaining computationally expensive. Vision transformers provide excellent capabilities for global understanding of image content, but tend to be data-hungry and resource-intensive. Graph neural networks appear frequently for handling structured data and modeling relationships between image elements or scene objects. Multi-modal fusion techniques combine complementary information from different sources, like vision, text, and audio, to achieve better overall performance. Parameter-efficient fine-tuning methods allow adaptation of large pre-trained models with minimal computational resources by updating only a small subset of parameters. Each methodology has distinct strengths, limitations, and appropriate use cases, with researchers often combining multiple approaches to address specific challenges. Many papers focus on improving efficiency and reducing computational requirements, reflecting the growing importance of deploying sophisticated computer vision systems on edge devices with limited resources. Let's examine our first selected paper in greater detail. Predicting Road Surface Anomalies by Visual Tracking of a Preceding Vehicle by Jehoda and colleagues. This work represents a paradigm shift in road hazard detection by tracking the motion of vehicles ahead rather than observing the road surface directly. The key insight driving this research is that when a vehicle encounters a road anomaly, its motion changes in subtle but detectable ways. By analyzing these motion patterns, it's possible to infer the presence and location of road hazards without directly observing them. This approach works remarkably well in conditions where direct observation is impossible, such as low light, heavy rain, or when the road is obscured by other vehicles. The system provides several seconds of advance warning before encountering hazards, giving sufficient time for evasive maneuvers or system adjustments. What makes this particularly practical is that it uses standard cameras already common in modern vehicles, without requiring specialized hardware. This paper was selected for highlighting because it fundamentally transforms how road safety challenges are addressed, leveraging the network effect of vehicles on the road where each vehicle becomes both a sensor and a beacon for others. Our second selected paper, VideoPath-LLaVA by Wang and colleagues represents the first model to effectively mimic pathologists' diagnostic process using video analysis of tissue samples. While existing models have made progress in analyzing static pathology images, they typically fail to capture the dynamic, exploratory nature of pathological examination. VideoPath-LLaVA integrates three distinct image scenarios: single-patch images, automatically extracted keyframes from videos, and manually segmented video pathology images. The model generates detailed histological descriptions that culminate in a definitive diagnosis, bridging the gap between visual narratives and diagnostic reasoning. The researchers overcame the significant challenge of data scarcity in the medical domain by creating VideoPath-Instruct, a dataset comprising over 4,000 video and diagnosis-specific instructional pairs sourced from educational histopathology videos. They then developed a novel instruction tuning approach that effectively transfers knowledge from existing datasets to the more complex domain of video analysis. This paper was selected for its potential to transform AI-assisted medical decision-making by providing not just diagnoses, but also the reasoning behind them, enhancing transparency and interpretability. Our third selected paper, ONE2ANY by Liu and colleagues, fundamentally changes how we approach 6D object pose estimation problems. Traditional methods typically require complete 3D models, multiple reference views, or category-specific training, creating significant barriers to real-world deployment. ONE2ANY breaks these dependencies by requiring only a single reference image and a single query image, without prior knowledge of the object's 3D model, multi-view data, or category constraints. This is achieved through a novel encoding-decoding process that captures comprehensive information about an object's shape, orientation, and texture from just one reference view. The authors developed a robust feature extraction and matching mechanism that can identify corresponding points between images even under significant viewpoint changes, combined with a transformer-based architecture that effectively aggregates information across these correspondences. Perhaps most impressively, ONE2ANY generalizes to objects from categories not seen during training, making it immediately applicable to new scenarios without requiring additional data collection or model fine-tuning. This paper was selected because it removes fundamental limitations that have constrained pose estimation applications in augmented reality, robotics, and human-computer interaction. Looking toward the future of computer vision research, several clear directions are emerging. We anticipate continued efficiency improvements for edge deployment of diffusion models, making these powerful generative systems practical for mobile and embedded devices. Further integration of multiple modalities will likely accelerate, combining vision with language, audio, touch, and other sensing modalities to create more comprehensive AI systems. We expect to see more robust 3D understanding from limited information, reducing dependencies on extensive training data or prior knowledge. Specialized applications will continue to emerge in healthcare, transportation, and security, often requiring interdisciplinary collaboration to address domain-specific challenges. Additionally, as synthetic content becomes increasingly realistic and accessible, addressing media authenticity challenges will become even more critical. The field is moving towards systems that are not only more capable, but also more efficient, adaptable, and trustworthy, opening new possibilities for how AI can enhance our interaction with the visual world. A note on how this presentation was created: the content was synthesized using CLAU-D-3-7-SONNET-20250219 from Anthropic with text-to-speech narration generated using DeepGram. Slide visualizations were created with Grok, and human expert review was conducted to ensure accuracy and relevance. While the content has been extensively reviewed, some oversights may exist in the synthesis process. This approach represents the growing capability of AI systems to assist in research synthesis and communication, though human expertise remains essential for verification and contextualization. The technologies used demonstrate how AI can help disseminate complex technical information in accessible formats, potentially accelerating the pace of knowledge sharing within the research community. We hope you found today's exploration of computer vision research insightful. To stay updated with the latest developments, subscribe to our channel for daily research updates. New episodes are released every weekday covering the latest AI research across various domains. Follow us on social media for additional insights and behind-the-scenes content. We also welcome your suggestions for topics or papers to cover in future episodes. Join our growing community of AI enthusiasts and researchers to participate in discussions about cutting-edge developments. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archives. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.